Good morning, everyone, and welcome to today's presentation. I'm excited to have you here as we explore the fascinating world of roads. Today's topic is road, where we'll cover an introduction, definitions, types, and the road profile. We'll also delve into the geometrical design of roads, including demarcation, alignment in plains and hills, curves, and drainage. Additionally, we'll look at different types of roads like WBM and earthen roads, along with road maintenance and signage. Over the next few slides, I'll guide you through these key aspects to give you a comprehensive understanding. So let's get started. Let's talk about roads and their vital role in rural development. Roads are not just pathways. They are the backbone of connecting rural areas to essential social and economic infrastructure. Without good roads, access to services like healthcare, education, and markets becomes very limited, which hinders growth. In fact, roads indirectly influence the broader process of development by shaping people's socioeconomic attitudes. When people can easily reach markets, schools, and health centers, it promotes a more positive outlook towards growth and progress. Moreover, improved roads help disseminate knowledge more quickly and effectively, reducing inequalities within rural communities. This ultimately leads to a better quality of life, as opportunities become more accessible to everyone. So, as we explore the broader picture of rural development, remember that roads are a key driver. They connect, they empower, and they transform. Roads play a crucial role in our development. They are very essential to promoting and sustaining agricultural growth by providing farmers access to markets and resources. They also improve basic health and hygiene by enabling easier access to healthcare facilities. Additionally, roads open up opportunities for education, giving children and adults alike access to schools and learning centers. Beyond that, roads are vital for providing access to economic opportunities, helping local businesses grow and attracting investments. They create employment opportunities, both directly through construction and maintenance, and indirectly by boosting other sectors. Roads also enhance democratic processes by allowing people to participate more easily in civic activities and bringing communities into the national mainstream. Furthermore, roads help in developing local skills by connecting people to training centers and markets. They reduce vulnerability and poverty by opening up new avenues for income and social mobility. Importantly, roads act as infrastructure multipliers, meaning they amplify the benefits of other investments, making development more efficient and widespread. In the overall picture, roads are not just physical infrastructure. They are a catalyst for inclusive growth and sustainable development. They tie together various aspects of progress, making communities more resilient and connected. Road connectivity is often seen as a key factor in boosting agricultural output and increasing the earning capacity of rural populations. When rural areas are better connected, farmers and local businesses can access markets more easily, which directly impacts their income and growth opportunities. But the benefits go beyond just economic gains. Improved rural connectivity significantly enhances quality of life. For example, it opens up better educational facilities for children and makes healthcare services more accessible and reliable. When schools and clinics are reachable, both students and patients benefit from more consistent attendance and treatment. Furthermore, good connectivity plays a crucial role in improving governance. It allows local authorities to deliver utility services more effectively and respond swiftly in emergencies. Overall, connecting rural areas isn't just about roads. It's about creating a foundation for comprehensive development that touches every aspect of community life, aligning perfectly with our overall goal of inclusive growth and sustainable development. Let's delve into road classification, which is essential for understanding how different roads function and serve various transportation needs. The most common way to classify roads is based on speed and accessibility. As a general rule, the more accessible a road is, the slower it tends to be because it accommodates more types of traffic, including pedestrians, vehicles, and sometimes even goods. Conversely, roads with less access tend to allow higher speeds, but serve more specific purposes. Starting with freeways, these are access-controlled, divided highways designed for fast and efficient travel. Most freeways have 4 lanes, 2 in each direction. But as they approach urban areas, they often expand to add more lanes to handle increased traffic. Access to freeways is tightly controlled through interchanges, which are designed based on the intersecting road type, whether it's rural roads or other freeways. This setup minimizes interruptions and maximizes speed. Next, we have expressways. Think of these as a step above regular highways. They're built for high speeds, often around 120 kilometers per hour, and are designed to handle large volumes of traffic safely. To achieve this, expressways typically feature grade separations at intersections, meaning there are no crossing traffic signals. It's important to note that on expressways, activities like parking, loading goods, unloading, or pedestrian movement are not permitted, ensuring smooth flow and safety. Finally, we come to highways, which are considered the backbone of a country's road network. They are classified into rural and urban highways. Rural highways pass through countryside and villages, connecting rural areas to larger towns, while urban highways traverse major cities and towns, facilitating urban transportation. These roads are crucial for regional connectivity and economic activity. Understanding these classifications helps us see how the road network is organized to suit different needs, whether it's high-speed travel, safe handling of large traffic volumes, or connecting remote areas. This framework is fundamental as we look at the overall transportation system and plan infrastructure development. Let's take a closer look at road classification, starting with arterials. These are the main streets designed primarily for through traffic, meaning they usually run continuously across different areas. You'll often find that they are divided highways with either fully or partially controlled access, which helps keep traffic flowing smoothly. Parking, loading, and unloading activities on arterials are generally restricted or regulated to avoid disruptions. Pedestrians are allowed to cross these roads, but only at intersections or designated crossings, ensuring safety and efficiency. Moving on to local streets, these are primarily meant for access rather than through traffic. Think of them as the streets you use to reach your home or business, shorter and less busy. They usually don't carry large volumes of traffic and allow unrestricted parking and pedestrian movement, making them more pedestrian-friendly and accessible for residents and local businesses. Lastly, we have collector streets. These roads serve as the connectors between local streets and arterials. Their main purpose is to collect traffic from neighborhoods and distribute it to the larger arterial roads. They also provide access to local streets, so full access is typically available here. During peak hours, parking restrictions might be enforced to help keep traffic flowing smoothly, but otherwise, these streets balance accessibility with traffic management. Understanding these classifications helps us design and plan better transportation systems, ensuring each street type serves its intended purpose efficiently within the overall network. Today, I'd like to talk about the IRC classification of roads. In the IRC road classification system, all roads are grouped into 5 main categories. These categories help us understand the importance and function of each type of road within the overall transportation network. The first category is national highways, or NH. These are the major roads that connect cities and states, facilitating long-distance travel and commerce. Next, we have state highways, or SH, which connect important towns and districts within a state, supporting regional connectivity. Then there are major district roads, or MDR, which serve to link districts to the state highways, ensuring smoother movement within districts. Following that, we have other district roads, or ODR, which are crucial for connecting smaller villages and local areas to the district road network. Lastly, village roads, or VR, form the foundation of the network, providing access within villages and to nearby roads. Understanding these classifications is key because it helps us prioritize maintenance, plan infrastructure development, and ensure efficient transportation. It ties back to our broader goal of improving connectivity and supporting regional development through targeted road planning and management. Let's take a closer look at the IRC classification of national highways in India. As many of you know, the National Highways Network is a critical part of our country's infrastructure, managed and maintained by the Government of India. By 2010, this network stretched over 70,934 kilometers, which is roughly 44,076 miles, and it includes some of the most vital routes, such as over 1,000 kilometers of limited-access expressways. These expressways are designed for faster, more efficient travel, reducing congestion and improving safety. The key agency responsible for this network is the National Highways Authority of India, or NHAI. It acts as the nodal agency, meaning it oversees the planning, construction, upgrading, and maintenance of most national highways. The NHAI operates under the Ministry of Road Transport and Highways, ensuring that these roads meet national standards and serve the needs of our economy and citizens. What's particularly interesting is how the NHAI often employs a public-private partnership model. This approach involves collaboration with private companies for developing, maintaining, and even collecting tolls on these highways. It's a strategic way to leverage private sector efficiency and investment, helping us build and sustain an extensive road network without overburdening public finances. Overall, these classifications and management strategies highlight how India is working to improve connectivity, support economic growth, and provide better infrastructure for all of us. Let's take a closer look at the IRC classification of roads. Starting with state highways, these are essentially the arterial roads of a state. They connect with national highways in neighboring states, link district headquarters, and important cities within the state. They also act as main arteries to and from district roads. In terms of scale, the total length of state highways across the country is about 137,119 kilometers, which highlights their significance in the network. Moving on to major district roads, these are important roads within a district that serve key areas of production and markets. They connect these areas with each other and with major highways. An example is connecting taluk headquarters to district headquarters, facilitating efficient movement of goods and people. India has approximately 470,000 kilometers of these major district roads, emphasizing their role in regional connectivity. Then we have other district roads, which primarily serve rural areas. These roads provide outlets for agricultural produce and connect villages to market centers or to larger roads like MDR or SH. Finally, village roads are the local connectors, linking villages or groups of villages to each other or to higher category roads like ODR or MDR. Out of the total road network, India has about 26.5 lakh kilometers of other district roads and village roads, which makes up a significant portion of the overall 33.15 million kilometers of roads. Overall, this classification helps us understand how the road network is structured to ensure connectivity from the smallest villages to major cities, supporting economic activity and development at every level. Let's take a closer look at the classification of rural roads in India. As you can see, rural roads are generally categorized into two main types: other district roads, or ODR, and village roads, or VR. Now, the village roads are further subdivided into two categories: Panchayat Union roads and Panchayat roads. Roads serving rural areas are primarily those that connect production areas to market centers, taluk head offices, or block headquarters. These are vital for rural development because they help facilitate the movement of goods and people. These roads usually serve villages with populations of 1,000 or more, or groups of smaller villages that are clustered together. Interestingly, these roads are owned by the Highways Department, which indicates their importance in the overall road network. On the other hand, village roads are those that connect villages with each other or link them to higher category roads like ODR or MDR. These roads fall under the control of the Rural Development and Panchayat Raj departments, emphasizing their role in local governance and community connectivity. It's also worth noting that India has a massive network of rural roads, over 26.5 lakh kilometers of ODR and VR, combined out of a total of over 33 lakh kilometers of all types of roads. This extensive network underscores the importance of rural connectivity in India's overall transportation infrastructure and development goals. Let's take a closer look at the details of Indian roads. The Indian road network stretches approximately 33 lakh kilometers, making it the second largest in the world. This vast network plays a crucial role in connecting different parts of the country, supporting economic growth, and facilitating mobility. When we talk about these 33 lakh kilometers, it's important to understand that it includes everything from national highways and state highways to rural roads and local streets. This extensive network is essential for the movement of goods and people across diverse terrains and regions. As we continue our discussion on infrastructure, keep in mind how this widespread road connectivity underpins many of India's development goals and efforts to improve transportation efficiency. Now, let's take a closer look at the road's classification criteria. Apart from the classifications provided by various planning documents, roads are also categorized based on several other important factors. These criteria help us understand the functional aspects and usage of different roads. First, we consider the classification based on usage. This means looking at how the roads are used, whether they serve local traffic, connect different regions, or handle heavy freight. Each type plays a unique role in the overall transportation network. Next, we look at classification based on the carriageway. This refers to the number of lanes or the width of the road, which directly impacts the capacity and speed of travel. A wider carriageway typically supports higher traffic volumes and faster movement. Finally, we classify roads based on the pavement surface. The surface material, whether it's asphalt, concrete, or other materials, influences durability, maintenance needs, and driving comfort. By understanding these classification criteria, we can better appreciate how roads are designed and optimized for their specific functions in the transportation system. This, in turn, helps us plan more effective and efficient road networks. Let's take a closer look at how roads are classified based on their usage. This classification helps us understand how roads serve different needs throughout the year. The key idea here is whether a road can be used during various seasons or weather conditions. First, we have all-weather roads. These are the roads that can be used regardless of the weather, meaning they are negotiable during all seasons, including the rainy or winter months. Of course, there are some exceptions, such as at major river crossings, where traffic might be temporarily interrupted, but generally, these roads are reliable year-round. They are essential for ensuring consistent connectivity. Next, we have fair-weather roads. These roads, on the other hand, are only negotiable during good, fair weather conditions. When the weather turns bad, say, during heavy rains or snow, these roads might become impassable or unsafe to travel on. Understanding these classifications is crucial because it influences planning, maintenance, and the development of transportation infrastructure. It also ties back to our overall goal of creating a resilient and accessible road network that meets the demands of different seasons and weather patterns. Let's take a closer look at roads' classification criteria, starting with the basis of carriageway. This classification primarily depends on the type of the carriageway or the road pavement. Now, when we talk about paved roads with a hard surface, we're referring to roads that have a solid, durable pavement course. These are called paved roads, and they include examples like stones, water-bound macadam, or WBM, bituminous macadam roads, and concrete roads. These paved roads are designed to handle higher traffic loads and provide smoother travel conditions. On the other hand, we have unpaved roads. These are roads that do not have a hard, durable layer like the ones I just mentioned. If a road isn't provided with at least a WBM layer, it falls into this category. Typically, earth roads or gravel roads are categorized as unpaved roads. They are generally less durable and are often used in rural or less trafficked areas. So the key point here is that the classification based on carriageway helps us understand the road's structural makeup and suitability for different types of traffic. This understanding is crucial when planning or designing road networks to ensure they meet the needs of the users and the environment. Let's take a closer look at how roads are classified based on their pavement surface. Essentially, this classification depends on the type of surfacing provided on the road. When we talk about surfaced roads, these are the roads that have a bituminous or cement concrete surface. You might be familiar with these as the smoother, more durable roads that are suitable for high traffic areas. On the other hand, we have unsurfaced roads, which are quite different. These are roads that do not have a bituminous or cement concrete surface. Instead, they are made up of soil or gravel. This classification is important because it influences the road's durability, maintenance needs, and suitability for different types of traffic. Surfaced roads, with their bituminous or concrete surfaces, generally offer better riding comfort and longevity. Unsurfaced roads, while more economical initially, may require more frequent maintenance and are often found in rural or less developed areas. Understanding these differences helps us plan and design better transportation networks that meet specific needs and conditions. Now, let's look at other criteria used for road classification. Besides the physical characteristics, roads can also be classified based on factors like traffic volume, the load they carry, and their location and function. For example, roads with high traffic volumes are often considered major routes, which are crucial for moving large numbers of people or goods efficiently. Similarly, the type of load transported, whether it's heavy freight or lighter vehicles, influences how we categorize these roads. Heavy loads may require stronger infrastructure and different maintenance standards. Finally, the location and purpose of the road matter a lot. A road serving a city center has different requirements compared to a rural or suburban road. All these criteria help us better understand the role of each road within the overall transportation network, ensuring we plan and maintain them effectively to meet their specific needs. Let's now look at some other criteria used for road classification. First, traffic volume. This is about how many vehicles use the road daily, and based on that, roads are categorized as heavy, medium, or light traffic. It's important to remember that these terms are relative, so the actual limits, like vehicles per day, can vary depending on the context. Next, we consider the load transported. Here, roads are classified based on the amount of load they carry, measured in tons per day. You might see classifications like Class I, Class II, or even A and B, depending on the system used. This helps in planning and design, ensuring roads can handle the expected loads. Finally, there's location and function. This is perhaps the most straightforward and accepted way to classify roads because it's based on where the road is situated and what purpose it serves. For example, whether it's an urban road, a rural highway, or an arterial road. In the Nagpur Road Plan, as we've seen earlier, classification heavily relies on location and function, which provides a clear and practical framework for planning and development. Connecting these points, you'll notice how these criteria help us understand the different roles roads play in our transportation system and how they guide our planning efforts. Let's talk about the alignment of roads. The alignment refers to the position or layout of the central line of the highway on the ground. Think of it as the roadmap that guides the road's path. Now, when we consider horizontal alignment, we're talking about the actual route of the road, whether it's straight or curved. Both these shapes are crucial for ensuring smooth travel and safety. Then there's vertical alignment, which deals with the elevation profile, whether the road is level or has gradients. This impacts things like visibility, drainage, and vehicle performance. Choosing the right alignment is incredibly important. A poorly planned alignment can lead to higher costs, not just during construction, but also in ongoing maintenance and vehicle operation. And once an alignment is set and built, changing it isn't simple or cheap. It involves acquiring additional land and reconstructing costly roadside structures. So, making the right decision early on saves a lot of trouble and expense down the line. This all ties back to our overall goal of designing efficient, safe, and cost-effective roads right from the start. When considering the requirements of an ideal alignment, the primary goal is to keep the route between two terminal stations as short as possible and as straight as feasible. Naturally, a straight and short alignment minimizes travel time and construction costs. However, in real-world scenarios, practical considerations often necessitate some deviations from this ideal. For instance, terrain features or existing infrastructure might require slight bends or adjustments. It's also crucial that the alignment is easy to construct and maintain. This ease of construction directly impacts the overall project timeline and budget. From an operational perspective, vehicles should run smoothly, which means designing easy gradients and gentle curves wherever possible. Sharp bends or steep slopes can cause operational difficulties and safety issues. Safety is another cornerstone of an ideal alignment. It's essential that the route remains safe both during construction and in operation. This includes paying special attention to slopes, embankments, and cuttings, ensuring they have safe geometric features. Proper design helps prevent accidents and structural failures. Lastly, the alignment should be economical. When we say economical, we're talking about minimizing the initial investment, maintenance, and operating costs. An optimal alignment balances these factors, ensuring that the project is financially sustainable over its lifespan. So, in essence, an ideal alignment is a careful balance, short and straight where possible, easy to build and operate, safe and cost-effective, aligning with the broader goal of designing efficient and sustainable transportation routes. This slide doesn't contain enough information. That's why we're moving to the next slide. This slide doesn't contain enough information. That's why we're moving to the next slide. Today, I will walk you through the cross-sectional elements of a road, which are essential to understanding how a road functions effectively and safely. First, let's consider the pavement surface characteristics. This includes the texture and material used, which directly impact safety, comfort, and durability. A well-designed surface minimizes skidding and ensures smooth driving. Next, drainage is a critical element that prevents water accumulation on the road, avoiding hydroplaning and structural damage. Proper drainage systems, like ditches and stormwater channels, are vital for maintaining road integrity. Camber refers to the slight upward curve of the road surface, which helps water runoff and improves safety by reducing the risk of water pooling. The width of the carriageway is also important. It needs to be sufficient for the volume and type of traffic expected, allowing for safe overtaking and lane discipline. Curbs serve as a boundary between the carriageway and other elements like footpaths or shoulders, providing structural support and safety. Road margins are the areas outside the carriageway, often used for drainage, utilities, or safety buffers. Shoulders are the areas beside the carriageway, offering space for emergency stops or breakdowns, and they also support the edge of the pavement. Parking lanes are designated areas for vehicles to park safely without obstructing the main traffic flow. Bus bays provide dedicated space for buses to pick up and drop off passengers, improving traffic flow and safety. Service roads run parallel to main roads, facilitating access to properties and reducing congestion on the main carriageway. Cycle tracks and footpaths are designated for cyclists and pedestrians, respectively, promoting safety and encouraging non-motorized transport. Guardrails are safety barriers installed at hazardous locations to prevent vehicles from leaving the roadway. Moving to the overall formation, the width of the formation refers to the entire cross-sectional width of the road, which must be designed carefully to accommodate all elements comfortably. The right-of-ways is the legal space allotted for the road, ensuring there's enough room for future expansion or utilities. By understanding these elements, we see how each part plays a role in creating a safe, efficient, and durable road system. They all connect to the broader goal of effective transportation infrastructure that serves the needs of users and the community. Let's take a closer look at the cross-section of the pavement. The features of this cross-section play a crucial role in determining not just how long the pavement lasts, but also how comfortable and safe it is for users. One of the key aspects here is the pavement surface characteristics. These are vital because they directly influence ride quality and safety. A smooth, well-maintained surface can significantly reduce vehicle wear and improve driver comfort, while a poorly designed or worn surface can lead to accidents and increased maintenance costs. Now, when we talk about the cross-sectional elements, things like camber, curbs, and the overall geometry come into focus. Camber, for instance, is that slight slope designed to facilitate water drainage, preventing water accumulation that could weaken the pavement. Curbs help define the edges of the roadway and assist in drainage and safety. And the geometry of these elements, how they are shaped and positioned, also impacts the pavement's performance and safety. Properly designed cross-sectional features ensure efficient drainage, minimize water-related damage, and enhance the overall riding experience. All these features are interconnected and contribute to the pavement's durability, safety, and comfort. As we continue, keep in mind how these seemingly small details can make a significant difference in the pavement's performance over its life cycle. Let's talk about pavement surface characteristics, which are crucial for safe and comfortable driving. There are 4 main aspects we need to consider. First is the friction between the wheels and the pavement surface. This friction is vital because it affects how well a vehicle can grip the road, especially in wet or slick conditions. Next, we have the smoothness of the road surface. A smoother surface not only provides comfort, but also helps in maintaining better control of the vehicle. Third, the light reflection characteristics of the pavement surface are important, especially for visibility during different times of the day or in various weather conditions. The way the surface reflects light can influence how easily drivers can see the road ahead. Lastly, drainage is essential to manage water on the surface. Proper drainage prevents water accumulation, reducing the risk of hydroplaning and accidents. All these factors are interconnected and play a significant role in ensuring that our roads are safe and comfortable for everyone. By paying attention to these surface characteristics, we can improve driving conditions and make transportation safer for all users. Let's talk about drainage. It's crucial that the pavement surface is absolutely impermeable, meaning water shouldn't seep through into the underlying layers. This helps prevent water damage and ensures the longevity of the pavement. Additionally, the way the surface is designed plays a big role. Both the geometry and the texture of the pavement surface should facilitate quick drainage. By designing the surface with proper slopes and textured patterns, water can flow off more efficiently, reducing the risk of water pooling and related problems. Overall, effective drainage is a key aspect of durable pavement design, helping us maintain safety and performance over time. Camber, or cant, refers to the cross slope that's intentionally provided across the width of the road surface. Its main purpose is to raise the middle of the road in the transverse direction, which helps in draining water away from the surface. Proper drainage is essential because standing water can cause damage over time and reduce safety. The key objectives of providing camber are quite important. First, it helps protect the surface itself, especially for gravel and bituminous roads. By ensuring water drains off efficiently, we reduce the risk of surface deterioration. Second, camber also protects the subgrade beneath the pavement by promoting proper drainage, which keeps the foundation solid and stable. Another critical point is safety. When water dries quickly from the pavement, it reduces the risk of skidding and accidents, especially during rainy weather. So, a well-designed camber contributes directly to safer driving conditions. However, it's important to strike the right balance. If the slope is too steep, it can cause erosion of the surface, which we definitely want to avoid. That's why camber is carefully measured, usually expressed as a ratio like 1 in 50 or a percentage such as 2%. And of course, the specific value depends on the type of pavement surface and the expected drainage needs. In essence, camber is a simple but crucial feature of road design that plays a significant role in maintaining the durability and safety of our roads. Now, let's take a closer look at the different types of camber. The most common ones you'll encounter are parabolic, straight, or sometimes a combination of both. Each of these has unique characteristics that influence the way a structure handles loads and distributes stress. Parabolic camber, for example, offers a smooth curve that can efficiently handle bending forces, making it very popular in bridges and large-span structures. On the other hand, straight camber is simpler and often used in shorter spans or where a more uniform shape is preferred. Sometimes, engineers combine these types to optimize performance for specific projects. Understanding these variations is key to designing safe and efficient structures, and it ties into the overall theme of structural optimization and innovation. Let's talk about the width of the carriageway. The width of the carriageway, or the pavement, primarily depends on two things: the width of the traffic lane and the number of lanes we have. Now, the width of each traffic lane is influenced by the size of the vehicles that will use the road, especially the maximum vehicle width, which is about 2.44 meters. But it's not just about fitting the vehicle. Safety is also a big concern. That's where side clearance comes in. Adequate side clearance not only improves safety, but also allows for better operating speeds. For a single lane, the desirable side clearance is around 0.68 meters. This means we need a minimum lane width of about 3.75 meters for a single lane road to comfortably accommodate vehicles and ensure safety. When we look at the clearance on either side of the vehicle, about 0.53 meters is typically required for each side, and in the center, around 1.06 meters. So, for a two-lane road, each lane should be at least 3.5 meters wide to maintain these clearances comfortably. In essence, these dimensions are critical because they directly impact safety, traffic flow, and the overall efficiency of the road network. Understanding these principles helps us design roads that are safe, functional, and capable of handling traffic smoothly. Let's take a closer look at the IRC specification for carriageway width. This slide highlights the key standards that guide how wide our roads should be to ensure safety and efficiency. The specifications are designed to accommodate various types of vehicles and traffic volumes effectively. It's important to understand that these guidelines help us maintain uniformity in road design, which ultimately improves traffic flow and safety. When planning or analyzing road projects, adhering to the IRC standards ensures that we meet national safety and quality benchmarks. Remember, the carriageway width is a critical factor in reducing congestion and accidents, making it a fundamental aspect of good road engineering practices. Curbs serve as important boundaries between the carriageway and the shoulder or footpaths. They come in different types, each designed for specific purposes. Let's start with low or mountable curbs. These are about 10 centimeters high and have a gentle slope, making it easy for vehicles to climb onto the shoulder if needed. They are typically used in medians and channelization schemes, and they also help with longitudinal drainage, allowing water to flow off efficiently. The idea is to encourage through traffic to stay within the main lanes while still providing access to the shoulder with minimal difficulty. Next, we have semi-barrier type curbs. These are a bit taller, around 15 centimeters high, and are used when pedestrian traffic is high. They act as a physical barrier to prevent vehicles from encroaching into parking areas. However, in emergency situations, vehicles can still drive over these curbs, though with some difficulty. They strike a balance between safety and accessibility. Then there are barrier-type curbs, which are about 20 centimeters high and have a steep batter. These are designed to strongly discourage vehicles from leaving the pavement, especially in areas with significant pedestrian activity. Their primary purpose is safety, keeping vehicles within the roadway and protecting pedestrians. Finally, we have submerged curbs, which are mainly used on rural roads. They are installed at the pavement edges between the pavement and shoulders. Their role is to provide lateral confinement and stability to the pavement structure, ensuring the road remains durable and well-supported in rural settings. Understanding these different curb types helps us design safer, more efficient roads tailored to the specific traffic and pedestrian needs of each area. Let's take a closer look at the different types of curbs. Curbs are an essential part of road design, serving both functional and aesthetic purposes. They help define the boundary between the roadway and footpath and also assist in managing water runoff. There are several common types of curbs, each suited to specific situations. For example, the *** vertical curb is the most typical. It provides a strong edge that helps contain the road surface and directs water towards drainage points. Then we have the *** rebated curb ***, which is slightly stepped and often used where vehicles need to access parking areas or driveways, offering a smoother transition for vehicles. The asterisk barrier curb asterisk is higher and more robust, mainly used for safety reasons, such as in areas where pedestrian safety is a priority or to prevent vehicles from crossing into restricted zones. Another type is the asterisk mountable curb asterisk, which is lower and can be easily driven over, commonly used in parking bays or residential streets to facilitate vehicle movement without damaging the curb. Understanding these different types helps us choose the right curb for each setting, ensuring safety, functionality, and aesthetic consistency. This ties back to our overall goal of creating well-designed, safe, and efficient roadways. Now, let's talk about road margins. The portion of the road beyond the main carriageway, on the roadway, is generally called the road margin. These areas play a crucial role in the overall safety and functionality of the road. Various elements make up the road margins, and I'll walk you through some of the key ones. First, we have shoulders, which provide extra space for vehicles to pull over in case of emergencies or breakdowns. Then, there are parking lanes, designated areas for vehicles to park safely alongside the road. Next, we have bus bays, which are specially designed to allow buses to stop without obstructing the flow of traffic. Service roads are also part of the road margin. They typically run parallel to main roads and help facilitate access to adjacent properties or facilities without disrupting main traffic flow. Cycle tracks are dedicated lanes for cyclists, ensuring their safety and encouraging eco-friendly transportation. Footpaths are essential for pedestrians, providing a safe space for walking away from vehicular traffic. Lastly, guardrails are safety barriers installed along the edges of roads or dangerous sections to prevent vehicles from veering off the roadway. All these elements together help to organize the road space efficiently, ensuring safety, accessibility, and smooth traffic flow. They are integral parts of the overall road infrastructure, supporting the primary goal of safe and efficient transportation. Let's talk about shoulders on the road. Shoulders are provided along the edge of the road and are primarily meant to accommodate stopped vehicles. They also serve as an emergency lane, which can be very important in case of breakdowns or accidents. Additionally, shoulders provide lateral support for the base and surface courses of the roadway, helping to maintain the overall stability of the road structure. It's crucial that the shoulder is strong enough to bear the weight of a fully loaded truck, even in wet conditions. This ensures safety and durability, especially during adverse weather. When designing shoulders, the width is also a key consideration. It should be wide enough to give enough working space around a stopped vehicle, allowing for safe repairs or emergency stops. Ideally, a width of about 4.6 meters is desirable for shoulders, providing ample space for safety and maneuverability. However, for two-lane rural highways in India, a minimum width of around 2.5 meters is recommended. This strikes a balance between safety and practicality, considering the typical traffic conditions. Understanding these points helps us appreciate how shoulders contribute to the safety, stability, and functionality of our roads, which ties back to our overall goal of designing safer and more efficient transportation infrastructure. Let's talk about parking lanes. These are the designated areas in urban streets where side parking is provided. They play a crucial role in organizing traffic and ensuring safety. Now, among the different types of parking, parallel parking is generally preferred. Why? Because it's safer for vehicles that are already on the move, reducing the chances of accidents or disruptions. When designing these parking lanes, it's important to ensure they have a minimum width of about 3 meters for parallel parking. This width provides enough space for vehicles to park comfortably and safely, while also allowing room for opening doors and pedestrian movement. Overall, properly designed parking lanes help maintain smooth traffic flow and enhance safety for everyone on the road. Let's talk about bus bays. These are created by recessing the curbs at bus stops, which essentially means carving out a section of the curb to allow buses to pull in without blocking the main roadway. The main purpose of this design is to ensure that buses can stop and pick up or drop off passengers smoothly, without obstructing the flow of traffic behind them. It's also important to position these bus bays carefully within the overall traffic layout. They should be located at least 75 meters away from intersections. Why is that? Because placing them too close to intersections can disrupt the movement of vehicles approaching or leaving the junction, leading to potential congestion or safety issues. So, in the context of efficient traffic management, bus bays are a strategic feature. They help maintain smooth vehicle flow on the main carriageway while accommodating public transportation needs. This balance is crucial in designing roads that are both accessible and efficient for all users. Service roads, also known as frontage roads, play a crucial role in our highway system. They provide access to access-controlled highways like freeways and expressways, which are designed for high-speed, long-distance travel. These roads run parallel to the main highway, creating a separate pathway alongside it. Usually, you'll notice that they are isolated from the highway itself by a separator, ensuring safety and clear separation. Access to the highway from these service roads is only allowed at specific points, which helps manage traffic flow efficiently. The main purpose of these roads is to reduce congestion on the expressway or freeway by allowing local traffic to enter and exit without directly impacting the high-speed lanes. This setup also ensures that the overall speed of traffic on the main highway remains high, as vehicles entering or leaving don't have to weave through slower-moving local traffic. Connecting these points to the broader theme of highway design, service roads are essential for balancing accessibility and maintaining high-speed travel, ensuring that our highways are both efficient and safe for everyone. Now, let's talk about cycle tracks. These are specially designated lanes for cyclists, and you'll typically find them in urban areas where cycle traffic is quite high. The idea is to create a safe and efficient space for cyclists to travel without interference from motor vehicles. A key point to remember is that the minimum width for a cycle track should be at least 2 meters. This width helps ensure safety and comfort for cyclists. Additionally, if the volume of cycle traffic increases, the width of the cycle track can be expanded. For each additional track or increased volume, you should add approximately 1 meter to the width. Overall, cycle tracks are an essential part of urban planning aimed at promoting sustainable transportation and reducing congestion. They help integrate cycling into the city's transport network seamlessly and safely. Let's talk about footpaths. Footpaths are essentially the exclusive right-of-way for pedestrians, especially in busy urban areas. They are designed to keep pedestrians safe by providing a dedicated space where they can walk without having to worry about vehicles. When both pedestrian and vehicular traffic are high, footpaths become even more crucial for safety. The minimum width for a footpath is typically 1.5 meters, but this can be increased depending on the volume of foot traffic. The goal is to ensure comfort and safety for everyone. Also, the surface of the footpath should be smooth, at least as smooth as the surrounding pavement, if not smoother. This encourages people to use the footpath comfortably and safely. Remember, well-designed footpaths are an important part of creating safer, more accessible urban environments that prioritize pedestrian movement, which aligns with our overall goal of better urban planning. Let's talk about guardrails. These are typically installed at the edge of the shoulder, especially when the road is situated on an embankment. Their main purpose is to prevent vehicles from accidentally running off the edge, which is particularly critical when the height of the embankment exceeds 3 meters. You might notice that there are various designs of guardrails, but a common feature is the use of guard stones painted in alternating black and white. This color pattern isn't just for aesthetics. It actually helps improve visibility, especially at night when headlights illuminate the curves. So, in essence, guardrails are a vital safety feature that not only prevent accidents, but also enhance driver awareness and visibility in challenging conditions. Today, we're going to focus on the width of formation, which is a critical aspect of roadway design. The width of formation, or roadway width, refers to the total measurement across the paved surfaces. This includes the widths of pavements or carriageways, as well as separators and shoulders. It's important to note that this measurement does not account for any extra land used in formation or cutting. Essentially, we're talking about the actual paved area dedicated to traffic movement. The Indian Roads Congress, or IRC, provides recommended values for these widths, which you can find detailed in their table. Understanding these dimensions helps us ensure the road is designed for safety, efficiency, and proper traffic flow, aligning with the overall goal of effective transportation infrastructure. Let's talk about the right-of-way, or row, which is essentially the width of land we acquire for the road along its alignment. It's important that this width is sufficient to accommodate all the cross-sectional elements of the highway, like lanes, shoulders, and drainage, and also leave some room for future development. To prevent what we call ribbon development, where buildings spread uncontrollably along the highway, we often establish control lines and building lines. The control line indicates the nearest limit where uncontrolled building activity might occur in the future. In contrast, the building line is a specific boundary on either side of the road, within which no building activity is allowed at all. This setup helps us manage land use effectively and keeps the highway corridor orderly, ensuring safety, efficiency, and room for future growth, all of which are crucial aspects of highway planning. The right-of-way width is influenced by several important factors that we need to consider carefully. First, the width of formation, which depends on the category of the highway, as well as the width of the roadway and the road margins. Essentially, wider roads or those designed for heavier traffic will require a broader right-of-way. Next, we look at the height of embankments or the depth of cutting. This is governed by the topography of the area and the vertical alignment we plan for the road. Steeper terrain or more complex alignments often mean more land needs to be cleared or reserved. Then, we consider the side slopes of embankments or cuttings. These slopes depend on factors such as the height of the slope itself and the soil type. For example, loose or sandy soils might require gentler slopes to ensure stability, which in turn affects the width of the right-of-way. Drainage systems are also crucial. The size and design of drainage channels depend heavily on local rainfall and topography. Proper drainage is vital to prevent water accumulation and erosion, so we must account for these factors when planning the land width. Sight distance considerations are another key point. On curved sections or areas with obstructions like buildings, visibility can be restricted on the inner side of the curve. Ensuring adequate sight distance is essential for safety, which sometimes means widening the right-of-way in these zones. Lastly, we should reserve land for future widening. As traffic grows and development progresses, roads often need to be expanded. Acquiring some land in advance helps facilitate future widening projects without significant disruptions or additional land acquisition costs. Overall, these factors are interconnected and vital for designing a safe, efficient, and sustainable highway. Understanding them ensures that we allocate the right-of-way appropriately, balancing current needs with future growth. Let's talk about the importance of reserved lands. The key point here is that having reserved land is crucial because it provides extra width, which is really beneficial when constructing roadside facilities. This extra space allows us to plan and build necessary infrastructure without feeling constrained. Another important aspect is that once the land is developed or built upon, acquiring more land later becomes very difficult. This is because the land might be occupied for various other purposes, like buildings or businesses, making it almost impossible to expand or modify later on. Additionally, the normal right-of-way requirements differ between built-up areas and open spaces. Ensuring reserved land meets these requirements helps us maintain safe and efficient road design. Overall, reserving land up front helps us avoid complications down the line and ensures that the infrastructure we plan is both functional and sustainable. It's a strategic step to support the overall success of the project. Today, I want to talk about the concept of right-of-way. This is a fundamental idea in traffic management and safety. Essentially, it determines who has the legal priority to go first in different situations. Understanding the right-of-way helps prevent accidents and keeps traffic flowing smoothly. For example, at intersections, there are specific rules that specify who must yield and who can go first. Usually, vehicles on the main road or those already in the intersection have the right of way. Pedestrians also have rights, especially at crosswalks. Recognizing these rules and respecting them is crucial for everyone's safety. Remember, the key point is that right of way isn't just about who gets there first. It's about understanding and following the established rules to avoid confusion and collisions. This concept ties directly into the overall theme of traffic safety and efficient road use. By being aware of and respecting right of way, we contribute to safer roads for all users. It's a simple but powerful way to promote responsible driving and pedestrian behavior. Let's take a closer look at the construction of roads, specifically the pavement components. Starting from the bottom, we have the subgrade, which is essentially the natural soil prepared to support the layers above. It's crucial because it provides the foundation for the entire pavement structure. Above that is the subbase, a layer of processed material that offers additional stability and drainage. Next comes the base layer, which is typically made up of crushed stone or gravel, providing the main load-bearing capacity of the pavement. Finally, on top, we have the surface course, which is the actual driving surface, often asphalt or concrete, that ensures a smooth, durable ride. Understanding these components helps us appreciate how each layer contributes to the overall strength and longevity of the road. Remember, each layer plays a vital role in ensuring the pavement can withstand traffic loads and environmental conditions over time. Now, let's talk about the subgrade. The load from the pavement is transferred effectively by the subgrade to the earth beneath. It's important to note that often, we use the locally available earth to construct the subgrade. However, this earth must have the required strength to support the loads and prevent future issues. If the natural earth isn't strong enough, we need to improve it or add materials to ensure it can handle the stresses. This step is crucial because the stability of the entire pavement depends on the quality of the subgrade. When constructing the pavement components, understanding and properly preparing the subgrade lays the foundation for durable and long-lasting roads. Let's talk about the subbase and base course in flexible pavements. These layers play a crucial role in dispersing the loads from traffic over a large area, which helps increase the pavement's load-bearing capacity. Essentially, they act as a supportive foundation that spreads out the stresses to prevent failures. The materials used for these layers typically include broken stones, gravels, or aggregates that can be either bound or unbound. Interestingly, bricks can also sometimes be used as subbase or base materials, offering additional options depending on the construction needs. It's important to note that the subbase layer generally consists of lower quality aggregates compared to the base course. This is because the subbase doesn't need to withstand as much load, and using inferior materials helps keep costs down without compromising the overall performance. Another key point is that smaller aggregates are usually preferred in these layers. Larger gravels tend to sink into the underlying soil when subjected to heavy loads, which can cause unevenness or instability. Smaller aggregates help maintain the layer's integrity and stability under traffic. In the case of rigid pavements, the functions of the subbase and base layers become even more critical. They help check the pumping action, which is the upward movement of fines or water under repeated loading, and they also protect the subsurface from frost action, which can cause significant damage during cold weather. So these layers are not just about supporting the pavement structure. They also contribute to its durability and longevity by addressing specific challenges like load distribution, frost protection, and preventing pumping. Overall, a well-designed subbase and base course are vital for constructing durable and resilient roads. The wearing course is the topmost layer of the pavement, and its main job is to provide a smooth riding surface for the traffic. Because it bears the brunt of all the abrading forces from vehicles, it needs to be highly durable. That's why we construct this layer with superior quality aggregates. These are the best materials to withstand the maximum loads and wear over time. Another crucial aspect of this layer is waterproofing. We need to prevent water from penetrating into the lower layers of the pavement, as water can weaken the entire structure. In flexible pavements, we use bituminous concrete, which is well compacted to create a tight, waterproof surface. For rigid pavements, cement concrete serves the same purpose, and it is also carefully compacted to ensure no water can seep through. So, in essence, the wearing course is designed not only for durability and smoothness, but also to protect the underlying layers from water damage, which is vital for the longevity of the entire road. This slide doesn't contain enough information. That's why we're moving to the next slide. Let's talk about bituminous or blacktop roads and how they are constructed. First, we start with subgrade preparation, which is crucial because it provides a stable foundation for the entire pavement. Proper subgrade preparation ensures that the road can withstand traffic loads and weather conditions. Next, we move on to spreading coarse aggregate and compacting it. This step helps improve the stability and strength of the base layer. Then we prepare the base course, which acts as the main load-bearing layer, providing additional support. After that, a prime coat is applied. This is a bituminous layer that helps bond the subsequent layers together and prevents water infiltration. Following the prime coat, we spread the bituminous mix, which is essentially the asphalt or blacktop material. This is then compacted thoroughly, often using rollers, to achieve density and smoothness. Once the bituminous macadam is well compacted, a layer of sand is sprayed on top, which helps fill any small surface voids and enhances the binding of the final surface layer. Finally, once all these steps are completed and the surface is properly finished, the road is open to traffic. Each of these steps is vital because they ensure the durability, strength, and longevity of the blacktop road, connecting to the overall goal of constructing reliable and safe pavements. Today, I'll walk you through the process of constructing cement concrete roads, which are a critical part of modern infrastructure. First, we start with the preparation of the subgrades or subbase. This step involves ensuring that the ground beneath the road is properly compacted and stable, providing a solid foundation for the concrete. Once the subbase is ready, we move on to fixing the forms. These forms act as molds to shape the concrete and define the edges of the road, ensuring a smooth and precise surface. Next, we place the reinforcement, which is typically steel bars or mesh. Reinforcement is essential because it gives the concrete additional strength and durability, especially under heavy loads. After that, the concrete itself is mixed and laid. This step requires careful mixing to get the right consistency and then pouring it evenly over the prepared surface. Once the concrete is laid, compaction and finishing follow. Compaction removes air pockets and ensures the concrete bonds well, while finishing gives the surface a smooth and even appearance. Then, we proceed to curing, which involves keeping the concrete moist to allow proper hydration and strength development. This step is crucial for the longevity of the road. Finally, after curing, the road can be opened to traffic. This entire process, from preparation to opening, is designed to produce durable and long-lasting cement concrete roads that can withstand traffic and environmental conditions. Connecting all these steps highlights how each phase plays a vital role in building reliable infrastructure. Today, I want to focus on the concept of the earth road. When we talk about the earth road, we're essentially referring to the pathways and routes that connect different parts of our planet. These routes are vital because they enable movement, trade, and communication across continents and cultures. The key point here is that the earth road isn't just about physical pathways like highways or railways. It also symbolizes the interconnectedness of our world. In a broader sense, it represents how societies and economies are linked through these routes, allowing for the exchange of ideas, goods, and services. Connecting this to our overall theme, understanding the earth road helps us appreciate the importance of infrastructure development and sustainable transportation. It's about creating efficient, resilient routes that support global growth while minimizing environmental impact. So, in essence, the earth road is more than just a physical concept. It's a metaphor for the interconnectedness and progress that define our modern world. Let's talk about earth roads. An earth road is a type of road where the entire pavement is constructed using locally available earth material, which is preferable for cost and resource efficiency. To source this earth, borrow pits are usually located nearby, ideally outside the land width, where the required material can be extracted without disrupting the main land area. Now, when it comes to the design, the subgrade and surface of earth roads are given a larger camber, typically between 1 in 33 and 1 in 20. The main reason for this is to facilitate faster drainage, which is crucial to protect the road from moisture damage. Proper drainage helps prevent water from pooling and weakening the structure. However, there's a limit to how much camber we can use. The maximum camber value is generally 1 in 20. Going beyond this limit can lead to issues like the formation of cross ruts and even corrosion of the pavement soils. So, it's a balancing act, ensuring adequate drainage without compromising the road's structural integrity. Connecting this to the overall theme, effective earth road design hinges on understanding how to optimize the use of local materials while ensuring proper drainage and durability. It's about creating a sustainable, safe, and functional road that serves its purpose efficiently. Let's talk about the construction steps involved in the procedure. First, when it comes to the material, it's important to identify suitable borrow pits. These are typically located by surveying the land adjacent to the construction site. We look for areas that are easy to access and at a reasonable haulage distance to keep costs down. Before we begin excavation, we also need to remove any organic materials like trees, shrubs, and grass roots, as these can affect the stability and quality of the earth we're working with. Next, we move on to the location of the center line. To ensure accuracy, we mark the center line and the road boundaries directly on the ground using wooden pegs. These pegs serve as physical reference points throughout the construction process. To maintain the desired vertical profile of the road, we also drive reference pegs at specific intervals. The spacing of these reference pegs depends on how much work we plan to complete each day, helping us stay on track and ensure the profile remains consistent along the entire length of the road. This systematic approach to material selection and precise marking is crucial for the smooth progression of the construction and achieving the desired quality and alignment of the final road. Let's now move on to the construction steps involved in preparing the subgrade. The first step is the preparation of the subgrade itself, which is crucial for ensuring a stable foundation. To start, site clearance is necessary. This can be done either manually, with tools like spades, picks, and hand shovels, or mechanically, using equipment such as bulldozers and scrapers. The goal here is to remove all unwanted materials and debris from the site. Next comes excavation and the construction of fills. Again, these can be performed manually or with machinery. Excavators, haulers, and compactors play important roles here. Dozers, in particular, are very effective for hauling materials over short distances, making the process more efficient. After the excavation and filling are completed, shaping of the subgrade takes place. This involves ensuring the surface is properly contoured to the desired grade, camber, and longitudinal profile. Proper shaping is essential for drainage and load distribution. An important point to remember is that if compaction is done manually, it often won't achieve the required density. Instead, the subgrade should be left to consolidate naturally under atmospheric conditions to ensure it reaches the necessary strength and stability. The manual equipment used includes shovels, spades, pickaxes, baskets, rammers, and hand rollers. But for effective compaction, mechanical methods are preferred as they provide a more uniform and thorough compaction. Overall, the key to a successful subgrade is ensuring it is properly prepared, compacted, and shaped, as this underpins the durability and safety of the entire construction. Now, let's talk about the pavement construction process. First, the soil is dumped onto the prepared subgrade and then pulverized. It's common to use a mixture of different soils to achieve the desired properties for stability and strength. After that, we check the moisture content of the soil. If there's not enough moisture, we add more to bring it up to the optimum moisture content, or OMC. Once the moisture level is correct, the soil is mixed thoroughly, spread out, and then rolled in layers. It's important that each layer's thickness does not exceed 10 centimeters to ensure proper compaction. The choice of roller depends on the soil type, how much compaction we need, and what equipment is available. Our goal is to reach at least 95% of the dry density specified in Indian Standard Light Compaction tests, which indicates a well-compacted surface. After compaction, we check the camber, or the slight slope of the surface, to make sure it's correct, and if needed, we make adjustments. Moving on, once the surface is properly compacted, it's allowed to dry out for a few days. This drying period ensures stability before opening the surface to traffic. Only after this drying phase is complete do we open the pavement to traffic, ensuring durability and safety for users. This slide doesn't contain enough information. That's why we're moving to the next slide. Today, let's talk about water-bound macadam. This is a type of road construction where water plays a crucial role in the process. Essentially, water-bound macadam involves laying layers of crushed stones, which are then bound together with water and compacted properly. The water acts as a binding agent, helping the stones settle tightly and creating a strong, durable surface. One of the key points here is the importance of proper water content during the compaction process. Too much water can weaken the structure, while too little may prevent the stones from binding effectively. So, achieving the right moisture content is critical for durability. This method is quite significant historically, because it was one of the earliest and most widely used methods of road construction before asphalt and concrete became prevalent. It's especially useful in rural or less developed areas due to its simplicity and cost-effectiveness. Overall, water-bound macadam forms the foundation for many modern road construction techniques, highlighting how fundamental principles like proper water management can lead to long-lasting infrastructure. It's a great example of how traditional methods still influence contemporary practices. Water-bound macadam, or WBM, is a type of road surface that was actually suggested by a Scottish engineer named John Macadam. His idea was to create a durable and stable roadway using specific materials and construction techniques. The core of this road's wearing course is made up of clean, crushed aggregates. These aggregates are mechanically interlocked by rolling, which helps create a solid structure. Then, you bind these aggregates together with filler material and water, which helps to lock everything in place. The entire layer is laid on a well-compacted base course to ensure stability and strength. This method results in a robust, permeable road surface that has been used effectively for many years. Overall, water-bound macadam is a great example of how understanding materials and construction methods can lead to durable and cost-effective roads. Water-bound macadam is considered superior in quality, and that's mainly because of the way the materials are carefully graded before use. When we compact the mixture, it forms an almost voidless mass, which is crucial for durability. The key here is the interlocking of the aggregate particles. This natural locking provides the necessary strength for the road, making it quite resilient. Plus, these interlocked particles help prevent the plastic materials from the subgrade from entering the voids, which can otherwise cause issues later on. Another important point is cost. Water-bound macadam tends to be less expensive compared to bituminous base courses, making it an economical choice for many projects. Overall, the combination of quality, strength, and cost-effectiveness makes water-bound macadam a reliable and popular choice in road construction. Now, let's discuss the disadvantages of water-bound macadam, or WBM roads. One of the main issues is that the stone pieces are only held together by sand and clay, with no cementing material added. This means that the binding relies heavily on pressure and moisture conditions. If either of these changes, the stability of the road can be compromised. Another critical point is how these roads perform under the weight of fast-moving vehicles. When a vehicle travels quickly over a WBM road, the slurry of sand and clay can get sucked out by pneumatic tires, which are common on modern vehicles. This process disturbs the stone pieces, causing the surface to disintegrate over time. As a result, WBM roads are generally not suitable for high-speed vehicles with pneumatic tires. Instead, they are better suited for slow-moving traffic, such as tongas or bullock carts, which exert less force on the surface. Additionally, constant use by iron-wheeled vehicles can crush the road metal, further reducing the lifespan of the road. Taking all these factors into account, we can see that WBM roads tend to have a relatively short lifespan, especially under heavy or fast traffic conditions. Let's talk about road maintenance. The Indian Roads Congress defines it as routine work performed to keep the pavement, shoulders, and other facilities for road users in good condition. Essentially, it's about maintaining the roads so they function as intended. This work aims to keep everything as close as possible to their original, constructed condition, even under normal traffic and natural forces. Maintenance is really crucial because it ensures the pavement structure delivers the best possible service throughout its lifespan. Without regular upkeep, the road's performance can deteriorate quickly, leading to safety issues and higher repair costs down the line. So, in the context of overall road infrastructure, proper maintenance isn't just about fixing things when they break. It's about proactive care to extend the life of our roads and ensure they serve us efficiently and safely for years to come. Today, I want to talk about road maintenance, an essential aspect of keeping our transportation systems efficient and safe. Proper road maintenance involves regular inspections, timely repairs, and preventive measures to extend the lifespan of our roads. By investing in maintenance, we not only improve safety for all users, but also save money in the long run by avoiding costly repairs caused by neglect. It's important to highlight that maintenance isn't just a one-time effort. It's an ongoing process that requires careful planning and prioritization based on road conditions and usage. Connecting this to our overall theme, effective road maintenance supports economic growth, reduces traffic disruptions, and enhances the quality of life for our communities. So, ensuring consistent and proactive maintenance is truly a key component of sustainable transportation infrastructure. Let's talk about road maintenance. This is a crucial aspect of infrastructure management that often doesn't get enough attention. Proper maintenance ensures that our roads remain safe, durable, and efficient for everyone. It involves regular inspections, timely repairs, and preventive measures to address wear and tear before they become major issues. By investing in maintenance, we extend the lifespan of our roads and reduce long-term costs. This ties into our overall theme of sustainable infrastructure, emphasizing that proactive upkeep is more cost-effective and beneficial for the community in the long run. Remember, well-maintained roads not only improve safety, but also support economic activities and enhance quality of life. Maintaining our roads is incredibly important, and there are several reasons why. First, it helps reduce the rate of deterioration, which means we protect the investments we've already made in construction and rehabilitation. When we keep the roads in good shape, we're essentially prolonging their lifespan and getting more value out of those initial costs. Second, proper maintenance lowers the cost of operating vehicles. When the road surface is smooth and in good condition, vehicles don't have to work as hard, which saves fuel and reduces wear and tear. This benefits everyone, from individual drivers to fleet operators. Third, safety is a major benefit of regular maintenance. Well-maintained roads are safer for all users, less risk of accidents caused by potholes or uneven surfaces. Safety is always a top priority, and consistent upkeep plays a big role in achieving that. Next, maintenance improves the reliability of the road. When roads are kept in good condition, they can stay open for traffic consistently, without unexpected closures due to damage. This reliability means more predictable and continuous transport services, which is vital for businesses and communities alike. Finally, all of these efforts contribute to broader social and economic benefits. Improved road access means better connectivity, which supports economic growth, social interactions, and access to essential services. So, maintenance isn't just about roads, it's about supporting the overall development and well-being of society. Let's talk about the types of maintenance and how they fit into our overall approach. The foundation of effective maintenance is damage control. This means we focus on intervening early, based on regular inspections of the road network. By planning and carrying out maintenance work at an early stage, we can counteract the negative effects caused by traffic and weather conditions. Maintenance is classified in different ways, either by how often we perform it or by the size and complexity of the activities involved. While our main goal is always preventive maintenance, we have to accept that some damages are unavoidable. That's where minor repairs come into play, becoming a regular part of our maintenance routine. Before fixing a defect, it's crucial to identify the root cause of the problem. Simply patching up the surface isn't enough if the underlying issue isn't addressed. In many cases, corrective actions need to go beyond just fixing the damage. We also need to deal with the cause to prevent future issues. This approach helps ensure that maintenance isn't just reactive, but proactive, aligning with our goal of sustaining a safe and durable road network over time. Now, let's talk about some common routine maintenance activities that are essential for keeping our roads in good shape. First, removing debris from the roadway and drains is crucial because it prevents blockages that can cause water to pool or lead to deterioration. Clearing drains ensures that water can flow freely, which is vital for preventing flooding and damage. Similarly, clearing culverts and other water crossings helps maintain proper drainage and avoid backups that could compromise the roadway. Repairing shoulders and side slopes is also important. They support the pavement and help prevent erosion. Patching potholes, sealing cracks, and repairing the edges of pavement are ongoing tasks that extend the life of the roadway and provide a smoother, safer surface for drivers. Additionally, cutting grass and bushes along the roadside improves visibility and safety. Maintaining road signage is equally important because clear, visible signs guide drivers and reduce accidents. All these activities, when performed regularly, contribute to the overall safety, durability, and functionality of our roads, making sure they serve the community effectively and efficiently. Let's take a closer look at a blocked culvert. When a culvert becomes obstructed, it can cause significant issues in water flow. This blockage might be due to debris, sediment buildup, or even small animals getting trapped. The key point here is that a blocked culvert can lead to water pooling or flooding upstream, which can damage infrastructure and disrupt local ecosystems. It's important to understand that culverts are essential for managing water movement beneath roads and pathways. When they are blocked, it not only affects water flow, but also increases the risk of erosion and structural failure over time. Addressing this problem promptly is crucial. Regular inspections and maintenance can prevent blockages from developing into major issues. This ties into our overall theme of proactive infrastructure management, keeping systems functioning properly to avoid costly repairs and environmental impacts. In summary, a blocked culvert isn't just a minor inconvenience. It can have serious consequences if left unaddressed. So, ongoing vigilance and maintenance are key to ensuring these structures serve their purpose effectively. Now, let's look at this issue of silt accumulating in the side drain. As we see here, over time, silt and debris tend to settle in these drains, which can significantly reduce their capacity. This accumulation can lead to blockages or reduced flow, which ultimately affects the drainage system's efficiency. It's important to regularly inspect and clean these side drains to prevent such buildup. Keeping the drains clear ensures that water can flow freely, especially during heavy rainfall, helping us avoid potential flooding or waterlogging. This is a crucial part of overall drainage management, as neglecting these small details can lead to bigger problems down the line. So, a proactive approach to maintaining side drains is key to ensuring the longevity and effectiveness of the entire drainage system. This slide doesn't contain enough information. That's why we're moving to the next slide. This slide doesn't contain enough information. That's why we're moving to the next slide. This slide doesn't contain enough information. That's why we're moving to the next slide. Traffic signs play a crucial role in maintaining safety and order on the roads. There are hundreds of different signs designed to cover a wide variety of traffic situations. and these signs are generally classified into three main categories. First, we have regulatory signs. These are the signs that drivers are required to obey strictly because they are essential for the safety of everyone on the road. They include speed limits, stop signs, and no entry signs, among others. These signs help regulate traffic flow and prevent accidents. Next, there are warning signs. These signs are primarily for the safety of the driver themselves. They alert drivers to potential hazards ahead, such as sharp turns, pedestrian crossings, or slippery roads. It's important to heed these warnings to avoid dangerous situations. Then we have informative signs. These provide useful information about the road ahead. They might tell you about facilities like gas stations, hospitals, or parking areas, or give details about the route, such as distances to destinations. Recognizing these signs helps drivers plan their journey better. In addition to these, there's a special category called work zone signs. These are used specifically during construction or road work. They warn drivers about ongoing work and are only placed temporarily. Once the work is completed and the road is restored to normal, these signs are removed. Understanding these different categories of traffic signs is essential because they collectively contribute to safer driving and smoother traffic flow. They help us anticipate what's ahead and make informed decisions on the road, which is all part of the overall goal of road safety and efficient transportation. This slide doesn't contain enough information. That's why we're moving to the next slide. This slide doesn't contain enough information. That's why we're moving to the next slide.